What I need to do next then is to insert the soil hydrometer into this suspension. Now, I'm not trying to take a reading at this point in time. I'm just trying to get my final volume to 1130 milliliters. When I place it in the suspension, I want to do so carefully because it's going to drop quite a bit when I release it. And I don't want this to go down and crash into the bottom of the cylinder, as it will likely break the hydrometer if I do that. So we can see from this that I've got a fair ways to go yet to bring it up to 1130 milliliter mark. I'm going to add water to do that with. Since I've got quite a ways to go, I'll add it this way initially. You notice how buoyant this hydrometer is, or how sensitive it is to movement. Now when I get close to the 1130 mil mark, then I'll go back and add it slower so I can get it at the right level. And we're reading volumes of water in cylinders or graduated cylinders. We read the bottom of the meniscus, and I'm not quite there yet. Now I'm at the 1130 milliliter mark. At some point in time during this part of the procedure, I need to also take temperature, because one of the things that will affect settling rate of these soil particles will be the temperature of the suspension. So in this particular situation, I'm going to go ahead and do that now and have you record that temperature so that you can use that in the formula to make your corrections as necessary. Now we're going to record temperature in degrees Celsius. And I'll simply hold the thermometer in there for a period of time until it's had a chance to equilibrate and give me the temperature in degrees centigrade. Now this water that we're using, this distilled water, has been setting in this container at room temperature for a period of several days, so I expect the water temperature will be slightly less than the room air temperature. But we've always got to check it, and when we do our 2-hour reading later on in this procedure, we'll need to check that temperature again because it may actually have changed slightly in that 2-hour time period. Okay, and reading the suspension temperature, we're at 23 degrees Celsius. So you should record that information, 23 degrees Celsius, because we'll need to use that information later on when we're doing the calculations on determining or correcting our formula for percentages of sand, silt, and clay. Well, obviously it's been way longer than 40-some seconds since we transferred this soil suspension into this cylinder. So what we need to do now at this point in time is we need to resuspend all of the soil particles that are in this suspension, and then at 40 seconds take a reading. Because at the end of 40 seconds, when we take a reading with this hydrometer, that will tell us what amount of soil is still in suspension, knowing that sand-sized particles will have settled out in that first 40 seconds. So the reading that the hydrometer will give us at the end of 40 seconds is actually telling us the amount of silt and or clay-sized particles that are still in suspension. When working with this hydrometer and taking it out, they're fairly round and they like to roll around, so I'm going to place this hydrometer on a paper towel, which will basically keep it from wanting to roll. Now granted, each time we do this, we've lost maybe a milliliter or two of water by removing the hydrometer and laying it out here. That is not a significant amount. That is not an amount that will cause our results to change significantly to what will affect our textural class for this soil. Now your lab handout says that we would use a plunger to resuspend these soil particles. In doing that, I've tried several different methods. Utilizing the plunger actually causes us to lose more moisture or more water and more volume out of the sample than the technique that I'm going to use today.